Hello, everyone, and welcome to our Capstone presentation. Today, we'll be presenting Compliant Intelligence, a citation-backed AI system designed to help users search and analyze consumer complaints more efficiently. My name is Michael Ha, and joining me today are Mark Villanueva and Alexander Zhuk. Let's get started. Here's a brief overview of today's presentation. We'll begin by introducing compliant intelligence and the problem it addresses. Next, we'll explore CFPB dataset and our key findings from exploratory data analysis. We'll then cover our data preparation process, modeling approach, and evaluation results before concluding it with a live demonstration, the project's impact, and future work. This project was a collaborative effort with each of us taking ownership of different parts of the pipeline. I focused on the exploratory data analysis and data quality work. Mark handled the data preparation, feature engineering, and deployment of the application. Alex focused on developing and evaluating our retrieval and classification model along with the error analysis and model validation. While we each had primary responsibilities, we worked together throughout the project to review the code, refine the report, and prepare the final presentation. Before diving into the technical details, I'd like to briefly summarize what we accomplished in this project. Complaint Intelligence transformed the CFPB Public Consumer Complaint Database into a citation-backed question answering system. Instead of relying on keyword search, user can ask question in plain English and receive answer grounded in relevant complaint narratives. In our evaluation, semantic retrieval significantly outperformed keyword search. We also uncovered two important issues along the way: a January 2026 policy change that reshaped the dataset, and a label leakage problem that initially inflated model performance. Both findings influence how we scope and validate the final system. The result is a working streamlined application that helps users find and verify complaint evidence more efficiently. Before explaining how our application works, I'd like to briefly introduce the data source behind it. The Consumer Financial Protection Bureau, or CFPB, is a U.S. federal agency that protects consumers in financial marketplace and maintain a public database of consumer complaints about financial products and services. Complaint Intelligence is an interactive web application that makes this information easier to explore. Instead of relying on keyword searches or manually reviewing thousands of complaints narrative, user can simply ask a question in plain English. The system retrieves the most relevant complaint and generate a concise citation-backed response, making it easier for compliance analysis, regulators, and consumer advocacy groups to identify emerging issues and verify the supporting evidence. Now that we've seen what complaint intelligence is, let's talk about the problem it was designed to solve. Every year, the CFPB receives millions of consumer complaints containing valuable information about fraud, servicing issues, and other consumer concerns. However, most of these insights are buried within free text narrative, making it difficult to search or analyze at scale. As complaint volumes continue to grow, manual review isn't simply practical, and traditional keyword search often miss complaints that describe the same issue using different language. This creates a real challenge for organizations trying to identify emerging consumer issues quickly and accurately. That challenge is what motivated us to develop complaint intelligence. Now that we discussed the problem, let's take a closer look at the data behind our solution. We used the CFPB public API to collect approximately 48,700 consumer complaints submitted between January and June 2026, with each row representing a single consumer complaint. As shown on the right, each complaint includes structured information such as product and issue, along with a free text narrative describing the consumer experience. While the structure field provides valuable context, the narrative is the primary input to our retrieval system. We convert these narratives into embedding, enabling semantic search based on meaning rather than exact keyword. Before building our retrieval system, we explored the dataset to better understand its quality and characteristics. Before jumping into modeling, we spent time exploring the dataset to understand its quality and characteristics. Overall, the data was in good shape, but our analysis also uncovered several patterns that influence how we prepare it. We found template complaints that needed to be removed, differences in complaint length across products, and product specific trends throughout the data. But the biggest takeaway came from a pattern we noticed in our data, and it ultimately changed the scope of our entire project. During our exploratory data analysis, we made what turned out to be the most important discovery of the entire project. As shown in the chart, both the share of credit reporting complaints and duplicated complaint narrative dropped dramatically beginning in January 2026. Rather than a gradual trend, this was an abrupt change suggesting that something external has changed. After investigating further, we found out that CFPB had introduced a new policy requiring consumers to first dispute credit reporting errors directly with the credit bureaus before submitting a complaint. This policy significantly changed the composition of the complaint data. Because of this, combining data before and after January 2026 would have mixed the two fundamentally different reporting environments. To maintain the consistent dataset, we scoped our analysis to complaints submitted between January and June 2026. This discovery ultimately influenced every stage of our project from data preparation through model evaluation. Now I'll pass it on to Mark to discuss the data cleaning and wrangling.
Hi, everyone. This is Mark, and I'll be talking about the data cleaning and wrangling. So, before any of this data could power our system, we had to clean it up, and this slide will walk you through the 3 steps that we took, starting with the biggest one. On the left, you'll see 9.2%, flagged as duplicate or templated. Here's what that really means. Out of all the complaints we pulled in, about 9 out of every 100 weren't really unique voices. They were near identical mass filed complaints. Think of it like a form that got submitted over and over rather than someone describing their own individual experience. And this wasn't spread out evenly. It was heavily concentrated in 2 categories: credit reporting and debt collection. If we left this in, our system would have essentially heard the same complaint repeated dozens of times and mistaken that repetition for importance. So we removed them before anything else touched the data. In the middle, redaction tokens removed, with examples like XXXX, dates, and dollar amounts. When the CFPB collects these complaints, they automatically blank out sensitive information, so things like account numbers or personal details, and then they replace them with placeholders like XXXX. That's great for privacy, but it's confusing for a model trying to understand meaning, since it would just see the same meaningless symbol over and over and not know what to do with it. So we strip those placeholders out before the model read the text. On the right, 3 low-value fields dropped: submitted via, date sent to company, and company public response. In plain terms, these were pieces of information that just weren't giving us anything useful. One was the same value on every single complaint, so it told us nothing. Another was basically a duplicate of information we already had elsewhere. And the third was missing on the majority of complaints and mostly boilerplate text when it wasn't. So rather than just carry around data that added noise without adding value, we simply removed it. So that's 3 steps, one clear priority. Get rid of anything that could distort what the model learns before it even had a chance to. So now we're going to talk about feature engineering. Once our data was clean, we had to decide what information the model would actually read. And this slide breaks down the 3 decisions that we made. First, the big one on the left. You'll see 3 words stacked up: product, issue, and narrative, flowing into something we called embedding input. Here's what that means in plain terms. Product is what kind of financial product the complaint is about. So this is like a credit card or a mortgage. Issue is the specific type of problem, say a billing dispute or an unauthorized charge. And narrative is the actual story the consumer wrote in their own words. We combined all 3 into a single piece of text before feeding it to our model. Why? Because giving the model that extra context up front, not just the complaint itself, but what category it belongs to, helps it recognize similar complaints more accurately, especially when someone's searching by topic. Then in the middle, you'll see narrative word count and needs chunking alongside that 38% figure. This simply means about complaint length. Some consumers wrote about a couple of sentences, others wrote paragraphs. Our model can only read so much text at once, so for any complaint that ran long, which is about 38% of them, we had to split it into smaller pieces, or chunks, so nothing got cut off or ignored. We built that logic in from the start, rather than forcing every complaint into the same size box. Finally, on the right, corpus structured for BM25 baseline. I know that sounds technical, so let me break it down. BM25 is just traditional keyword-based search method. Think of it like a smarter version of Control F, matching complaints based on shared words. So what we built is a newer approach called semantic search, which understands meaning, not just matching words. So it can find a similar complaint, even if the consumer used completely different language to describe the problem. We didn't want to just assume our newer, fancier approach was better, so we deliberately set up our data to let us test both methods side by side and prove which one actually performed better on real complaints, rather than just assuming. Now let's talk about privacy and ethics considerations. Protecting consumers in this project didn't stop at just hiding sensitive information. It actually shaped several decisions across our entire pipeline. This slide covers three of them, starting with the biggest. On the left, you'll see narrative clean and the original narrative, stacked one on top of the other. Here's the distinction. The CFPB automatically redacts sensitive details from every complaint, things like account numbers, before it's shared publicly. We took that redacted text and cleaned it further, stripping out leftover placeholder symbols so our model could actually understand it. That clean version, narrative clean, is what our model reads behind the scenes. But the original redacted narrative is still exactly what a user sees when they use our app. In other words, we never showed anyone a version of a complaint that didn't match what the consumer actually submitted. We just gave the model an easier to read copy to work with internally. In the middle, deduplication as a fairness guard. We touched on this earlier when we removed duplicate complaints, but it's worth calling out here specifically as a privacy and ethics decision, not just as a technical cleanup step. That field is duplicate narrative, flags mass filed repeated complaints. If we hadn't removed those, a handful of repeated filings could have made certain issues look far more common or far more urgent than they actually were. Removing them keeps our results representative of real individual consumer experiences, rather than skewed by whoever filed the same complaint the most times. And on the right, stratified demo subset. This one's about how the live app is deployed, not how it was evaluated. Hosting a tool like this online comes with real resource limits, memory, processing power, that kind of thing. So running our full data set of over 44,000 complaints every time someone opens up the app just isn't practical on a free hosting tier. So the live version you can try today uses a smaller, representative sample instead. But I want to be clear, every result, every number we're presenting in this project was calculated using the complete data set. The smaller sample is strictly a deployment convenience, not a shortcut we took in our actual evaluation.
We chose our metrics based on the stakeholder, not out of habit. We report precision at 5 and 10 because a compliance analyst reads a short list of results. So precision at small k mirrors how the tool actually gets used. And macro F1 for classification because it weights every product category equally. And that matters. An emerging harm pattern shows up first in small category, exactly the ones that raw accuracy would ignore. Just as important is what we deliberately did not report. We left out recall. Because with relevant sets in the thousands, it's mathematically pinned near zero and tells you nothing. We don't lead with raw accuracy because our 31 to 1 class imbalance means the model can look 29% accurate while being almost useless. That's why stratified splits and macro F1 aren't optional here. This is the slide I want to spend a moment on, the label leakage catch. An early version of our classifier scored 0.971 macro F1. On an 11 class problem with messy consumer written text, that is far too good, about 30 points above a well-tuned keyword model. And that's exactly what caught it. A number that good isn't a triumph, it's a red flag. When we dug in, we found a problem. Our data prep step had pasted the answer onto the front of every complaint, literally the product and issue labels. Right there, in the text the model was reading. So it wasn't classifying complaints, it was reading the label we handed it. Remove that, and the real score is 0.646. We report this rather than quietly fixing it because it's a failure mode specific to these RAG pipelines. Metadata belongs in the prompt, but it must never end up in the vector you search. Our pipeline Now, hard fails if a label ever reaches the encoder. Here's the headline, and it's deliberately two-sided. Both charts compare the same set of methods, and higher bars are better. Start on the left, retrieval. Each bar is one search method. On the far left, BM25 and TF-IDF, those are the keyword methods, the traditional baselines that match on exact words. On the right, mini-LM and BGE small, those are the semantic, meaning-based models. The number is precision at 5, out of the top 5 complaints returned, how many were actually relevant? And the meaning-based BG small wins. At 0.646, it finds a relevant complaint in about 65% of its top 5, versus 48% for keyword search. So for finding complaints, meaning beats keywords. Now the right chart, classification, and here it flips. Same kinds of methods, but now the keyword features on the left beat the meaning-based embeddings, 0.754 versus 0.642. Same data, opposite winner. Why the reversal? A meaning-based model compresses each complaint down to a few hundred numbers. The keyword method keeps 50,000 individual word features, and a complaint's product category is mostly decided by its vocabulary. So keyword features win when you're counting words, and meaning wins when you're matching intent. Reporting both is what makes the retrieval win credible. Two questions here: is the win real, and where does the system break? On the left, a paired bootstrap test says the precision advantage is statistically significant, p equals 0.01 and 0.001. But the mean reciprocal rank difference crosses zero, so we don't claim that we are better at ranking the single best hit. And hybrid retrieval gave no significant lift over dense alone, so we shipped the simpler design. Reporting what the evaluation ruled out is as useful as the positive result. Top right, the classification errors aren't random. They trace the seams of the taxonomy. An authorized transfer out of a bank account generally belongs to two categories, and that's exactly where the model fails. And bottom right, faithfulness, where I want to be honest, 6 of 6 cited claims were judge supported, but that number is soft. The citation behavior is uncalibrated. One answer cited nothing at all. Others cite all 5 sources on every claim. What matters is that our validation layer catches both directions, so the failures surface instead of passing silently. I want to be clear about what constrains these results, and this is separate from what we would do about them, which Mark will cover. 4 things. 1, our evaluation rests on 26 queries. That's up from 8, but still modest, so the confidence intervals are wide. 2, relevance is proxied by issue label, not a human reader. Our audit fixed 2 errors, but the proxy is still conservative. 3, we used off-the-shelf embeddings, never fine-tuned on complaint text, so the strongest version of our claim is still untested. And 4, this is a 6-month window, 1 extract, so generalization across time and policy changes is unverified. Let me take you to the live app, complaint-intelligence.streamy.app, and hand it the real questions so you can see the cited answer for yourself. This is our deployed artifact, a live tool a compliance analyst could open in the browser. It's searching over 43,000 consumer real complaints across 11 products. You can see top products like checking, credit cards, top issues, as well as top companies by complaint volume. The interesting thing is you see the window of 6 months of complaints. On the left are the controls, and analysts can filter by product. You also can see that we use BGE and Google's Gemini. And now let's ask a question. What problems are consumers reporting with debt collectors? The kind of open-ended question an analyst actually has, and the kind you can't answer with a keyword filter. Let's hit an enter, and behind the scenes, you will see that the system will be embedding the question. It retrieves the most relevant complaints by meaning and passes them to the language model to answer. Here's the answer: 4 concrete problems: failure to validate debts, collection without verification, poor communication, credit score harm. And the key part, at the end of every claim, a bracketed citation. Those citations aren't decorative. I can open any one. Here's the source 3. Behind that first claim, the consumer formally disputed the debt, and the company failed to produce proof they were legally responsible. That's the failure to validate, the answer summarized in the person's own words, with the state, the response, and the date attached. And it's not a one-off. Source 5, different company, different state, same story, dispute, no validation, continued collection. The pattern is real across complaints. And I can go one level deeper. The answer used the phrase withholding key documentation. Let me check it. If I search the complaints for withholding, no matches. So the model didn't copy the word, it paraphrased. But search document and it lights up inside sources 3 and 5. Consumers really did complain about missing documents. The answer is grounded in what people wrote, even where it's summarized rather than quoted. That's the receipts. That's the whole point, not a black box summary, but an answer an analyst can verify, claim by claim, down to the wording. That's the difference between a summary and evidence, exactly what a regulatory setting needs. And underneath the Q&A, the dashboard covers the broader trends. So in one interaction, we went from a plain English question to a cited, verifiable answer, drawing from tens of thousands of real complaints. That's the complaint intelligence. Thank you.
Now let's talk about the conclusion and what the project achieved. This project set out to answer one specific question. Could a system built on semantic search produce answers that are both relevant and faithful to real consumer complaints, reliable enough to actually support triage decisions by analysts and regulators? The answer is a qualified, evidence-backed yes, and this slide breaks down what that means. On the core result, dense semantic retrieval significantly outperformed traditional keyword search, surfacing a relevant complaint in roughly 2 out of 3 top results, compared to 1 out of 2 for keyword search. That's not a marginal difference. It's statistically significant and it translates directly into real-time SIG. An analyst spend less time sifting through irrelevant complaints before finding evidence they can actually use. On its core claim, our hypothesis is supported. Semantic retrieval measurably improves an analyst's ability to find relevant complaint evidence over the status quo. The second half of our hypothesis, faithfulness, is only partially supported, and we want to be precise about that distinction. Every claim we evaluated was in fact supported by its cited evidence. The system did not fabricate answers, but the way it cited that evidence was inconsistent, at times oversighting every retrieved complaint rather than one that actually mattered, and on one occasion citing nothing at all. Our system catches both of these failures rather than letting them slip through silently, which means the artifact is honest about its own limitations. But there's a difference between claiming an answer is faithful and claiming it's reliably grounded on every single response, and we're careful to only claim the former. Our most significant finding, though, wasn't about the numbers themselves. It was about how we got there. Early in this project, one of our models scored a 0.971 macro F1, an almost impossibly strong result for an 11-category classification task on messy, real-world text. So rather than accept that number, we investigated it and found that a labeling error had leaked the correct answer directly into what the model was reading. Once corrected, the real score was 0.646. This wasn't a footnote. It reshaped how every other result in this paper should be read, and it's the clearest evidence that our evaluation process was doing real work, not just producing favorable numbers. Practically, this project gives compliance analysts and regulators something they didn't have before. A tool that answers a plain English question with an evidence-backed response, traceable to specific complaints, not a static count, and not a search limited to exact keyword matches. Analysts and regulatory teams monitoring emerging harm patterns stand to benefit most directly, along with consumer advocacy organizations working with the same public data. So what does this actually change for the people who'd use it? This slide breaks down the shift this project represents, starting with what's different. Let's take a look at the left. Before this project, an analyst monitoring consumer complaints had 2 options: look at static complaint counts, or run a keyword search that only finds complaints using the exact same words as a query. Neither approach captures a complaint written in different language about the same underlying problem. So what we built changes that. Now, an analyst can type a plain English question and get back an evidence-backed answer, traceable to specific complaints that support it. That's the core shift, from counting and guessing to reading and verifying. Then in the middle, who actually benefits from this? Compliance analysts and regulators monitoring emerging consumer harm patterns are the primary audience, since they're the ones making real triage decisions based on this data every day. But it's not limited to them. Consumer advocacy organizations working with the same public CFPB dataset stand to benefit just as directly, since they're often asking the exact same kind of questions. What's actually gone wrong here and where? And on the right, how someone actually uses this today. This isn't a theoretical tool. It's a live working application hosted and accessible right now. A user types in their question in plain English. Our system pulls the most relevant complaints and returns a cited, evidence-backed answer they can independently verify. No technical background required, no keyword guessing, just a direct question and a direct, traceable answer. This is the practical difference this project makes, turning a public regulatory dataset into something someone can actually act on. So, if this project continued, where would we focus on next? This slide walks through our recommendations in the order that we'd actually tackle them. Priority first, foundation second, expansion last. Our highest priority is calibrating citation behavior at the moment an answer is generated, not just checking it afterward. Right now, our system catches oversighting and zero citation failures once they happen, but it doesn't prevent them from happening in the first place. This is our top priority because it's a targeted, achievable fix rather than a brand new modeling effort, and it directly addresses the clearest weakness we identified in our evaluation. It's the one that we talked about a few slides ago. Next, strengthening the foundation. Two things fall under this. First, expanding our query set. We evaluated our system on 26 handwritten queries, which was already a major improvement from where we started, but it's still a modest sample size, and growing it, alongside adding real human judgment, not just automated labels, would make our results even more defensible. Second, fine-tuning our embedding models specifically on complaint style language, instead of using them off the shelf. This would test directly whether the gap we saw in our classification results is a real limitation or just an artifact of using general purpose models that were never trained on this kind of text. And finally, expanding scope. So this comes last because it depends on everything else being solid first. That means moving our live application off its current smaller demo sample and onto the full data set. Then reintroducing the unsupervised topic modeling layer we originally planned for this project, something that could flag emerging complaint patterns before they're even reflected in the CFPB's official categories. We fix what's broken, strengthen what already works, and then expand what's possible. That's our roadmap from here. Thank you for your time. Our GitHub and the live application are both linked here if you'd like to explore them further. What started as a public dataset full of noise is now a tool someone can actually act on. That's complaint intelligence.